My name is Matt. I'm a developer ecosystem lead, now leading our developer relations team at LayerZero Labs. You can find me at Uncrappable on Twitter.
And today I'll be talking about LayerZero. I think some of the fundamental things to outline here before I get into Omnichain vaults is how LayerZero provides permissionless, censorship-resistant, and immutable bridge infrastructure. So with that in mind, let's dive a little bit deeper into how LayerZero works under the hood. LayerZero is an immutable interoperability protocol for building universal blockchain applications. There's a lot of buzzwords in that sentence, so let's try and break down a little bit more concretely what that actually means. All LayerZero does is it helps move standardized message packets between blockchains, meaning that I, as a developer, can move any arbitrary data from chain A to chain B. As part of that infrastructure, me, the application owner, can decide what security and validation logic actually makes sure that those messages are legitimate coming from chain A to chain B, and make sure that that message is delivered automatically for any of the users who interact with my app. Going a little bit deeper, what that looks like fundamentally is that some user on chain A will initiate a smart contract call. That smart contract call will be from your application, and your application will have defined within a LayerZero endpoint a type of message that you're sending, a destination chain that you want to send to, a configuration for what type of security and validation logic my application uses, and then that application will call the endpoint contract directly and emit that message to a destination chain. What that means is that a LayerZero message can move any arbitrary data on chain, whether that's token transfers, arbitrary call data, or both the token and the call data in the same call. What happens next is that messages are verified by your chosen verification set. DVNs are our term for it, decentralized verification networks. But the idea of a DVN is relatively straightforward. It means that any arbitrary validation system can not only attest that something happened on a source blockchain, but then write to the destination chain on your behalf that this message is valid. On the receiving side, the way that we protect your application is by, in the receiving endpoints logic, we check for how many block confirmations each validator waited for. We check for the expected DVN addresses to make sure it's coming from the verifiers that you expect. And then we set a threshold in the verification set as well to make sure that the correct number of verifiers deliver their attestations. So in this case, each individual DVN might be individual quorums. DVN1, for example, here might be a committee-based signer, which has 2 of 3 signature schema. DVN2 here might be something like Polyhedra's ZK bridge, which does ZK attestations to deliver ZK proofs to destination chain. And DVN3 may be something completely different. It could be a middle chain bridge like Axelar, for example. The point here is that after validation is achieved, we're able to seamlessly execute the message on the user's behalf on the destination chain because we know exactly what message bytes to deliver, and we've been given upfront an amount of gas to deliver for the destination app to execute its call logic. With that in mind, this system of being able to send, verify, and execute a message is the basis for how LayerZero under the hood works. That means that when you use LayerZero as an application developer, or as a vault issuer in this case, your app is not fixed to a single point of security or cost. You actually are able to take advantage of any point along this cost curve and choose and configure validation and security that matches the requirements and fee cost requirements of your application. And if new validation techniques ever become live, for example, ZK proofs in the last 5 years, you can seamlessly upgrade your application to the latest security model that's available for cross-chain interoperability, without having to worry about redeploying new contracts or dealing with any unintended state changes that you might be concerned about. With that in mind, the way that LayerZero provides execution is in 2 states. One is by just delivering calls atomically. So you can see here that an executor will call the LayerZero endpoint, call your application, and your app can do a traditional smart contract call into any number of applications here. But the downside is that if any one of these calls revert, the entire atomic operation reverts. So for DeFi developers, this can be challenging. How do we get around this problem? Well, LayerZero introduces a concept called horizontal composability. The way that horizontal composability works is that when the executor calls your endpoint and your application, you can store arbitrary bytes as part of the receive logic back into the endpoint, and then have the executor make a secondary call to any arbitrary smart contract that you want. This means that you can have standardized packeted atomic logic that's executed on-chain in separate segments of a transaction. And as we show here, this can be really, really valuable to vault operators. All of this builds to what I consider a omni-chain application. So with that in mind, let's look now specifically at token transfers. On a single chain like Ethereum or Linea, for example, token transfers are straightforward. You have a single atomic operation in one transaction where tokens are debited from one account and credited to another account on the same atomic network. With a cross-chain system, this is a little bit more complicated. You have to debit funds on one chain in a single transaction and credit on another. LayerZero makes this easy using what we call our Omnichain token standard. And as we see how this builds up to the Omnichain vaults in mind, this system allows you to have configurable message packets that are transferred between chains using a common OFT interface or Omnichain fungible token and easily move value from point A to point B. So how does this actually help users who are interacting with your vaults? Well, for Omnichain vaults, the main idea here is that a user from any chain, let's call that chain A, can deposit assets into your vault, an ERC-4626 vault, and receive their share token back out on any other chain that they want without having to bridge manually. How does this work under the hood? You see, with LayerZero O vaults, the process is actually relatively straightforward. On a single chain, right now today, ERC-4626 simply allows a user to have a token on that chain in their wallet, interact with the vault, deposit an asset, receive a share. With LayerZero, you have the ability to not only interact with this vault from a single source chain, but from any source chain and use a LayerZero OFT to transfer value into the hub chain, interact with the vault, and then receive a share token back out. What this looks like fundamentally is that as a user, I'm able to institute this LayerZero transfer, get those funds into my hub chain, and have deeper liquidity on that hub than I otherwise would in a single vault world. And that is very important because it makes it easier for you to coordinate liquidity with your users and make the actual process of depositing into these vaults straightforward. So that if I'm, for example, a user on Arbitrum, I can deposit my assets directly into your vault, regardless of what chain it's on, and get those assets immediately, or sorry, the shares immediately out into any other chain that I want to go to. So hopefully this gives you a good conception about how Omnichain vaults work. And if you want to talk more, I'll be here for 10 minutes after. But thank you guys so much.